video lesson on stoichiometry, working our practice test C. If you are working practice test C, you are in the round 2 opportunity for our stoichiometry lessons. Let's take a look at our first objective on our stoichiometry practice C. This is the objective where we learned how to interpret balanced equations in terms of particles, moles, mass, and volume. We will begin by reading through our equation that reads, write the balanced equation for the formation of gaseous hydrogen bromide from its elements. Gaseous hydrogen bromide, this will be a combination product where I'll point at hydrogen, who's a +1, bromide, who's a -1, and putting on the little symbol G for the gaseous phase. To make this product from the elements, we know that hydrogen and bromine both belong to the molecular diatomic club, H2 and Br2, and so to balance, we will need a 2 out front. The adjectives will include gaseous hydrogen and gaseous bromine, forming 2HBr. To interpret this equation in terms of particles, remember particles can stand for atoms, if we're looking at symbols all by themselves. They can represent molecules, which are when nonmetals combine, or they can represent formula units when we consider charges like is in HBr. Although hydrogen and bromine are both nonmetals, all of these particles will be termed molecules. We simply write one molecule of H2 reacts with one molecule of Br2 to form 2 molecules of our product HBr. Although HBr was written by charges, hydrogen is that exception. It carries a +1 charge, but it is a nonmetal. It is correctly called a molecule and not a formula unit. Coefficients stand directly for the number of interacting particles. Coefficients can also stand directly for the number of interacting moles. We would write 1 mole of hydrogen reacts with 1 mole of bromine to form 2 moles of HBr. Coefficients do not stand directly for the number of grams. When we write out our equation in terms of grams, we have to use the coefficient times the molar mass to come up with the grams. It's an old mole math problem where the coefficient stands directly for moles. Moles times molar mass will tell us our gram. So again, hydrogen, who has an atomic weight of 1, H2 would have a molar mass of 2 grams. We would begin by writing 2 grams of H2 reacts with bromine, who has an atomic weight of 80. 80 times 2 gives us 160 grams of bromine. The product HBr, finding its molar mass, hydrogen is 1, bromine is 80. The total sum there is 81. 81 times 2 would give us 162 grams of HBr, showing that we did indeed observe the law of conservation of mass, where the mass of the reactants does indeed equal the mass of the products. In the last equation, we use what's called molar volume, 22.4, times the coefficient to get us the liters for each of our reactants and products. Only if, and this is the case here, only if all reactants and products are gases can this equation be written. This example does show all reactants and products as gases. 1, the coefficient in front of hydrogen, times 22.4 shows 22.4 liters of hydrogen, reacting with 22.4 liters of bromine, forming 44.8 liters of our HBr. Not by adding the 2, but because the coefficient was 2 in front of the product, 2 times 22.4 gave us 44.8. With this reaction, the number of molecules was conserved, the number of moles was conserved, mass is always conserved, and indeed this also showed molar volume being conserved. And that's because 1 + 1 does indeed equal 2. That's a unique situation to this reaction. When yours matches this, give me an A+ on the bottom. Thank you.